All right, hey everyone, welcome back. This lecture is going to be on marine resources and pollution in our oceans. At the end, make sure you check out the couple of videos that will be posted, as those will relate to the information discussed within this lecture. All right, so let's get going. First thing I want to talk about is oil and natural gas. This is probably the biggest natural resource that we have in our oceans. And if you think back to when we started this term, I talked about how the oceans make up most of our planet, right? They cover 70% of the Earth's surface, and so they cover a lot of the crustal material that makes up the planet, so the oceanic crust. And so when we understand that oil and natural gas, these resources that we use to do a variety of things, not just power our cars, the processes that developed that material took millions of years. So basically what it is that plant and organic matter die and get buried over tons of sediment. And then in that process, because the sediment is pushing down on it and trapping that organic material, the hydrocarbons get trapped within the Earth's crust. And over time, it decays and it becomes natural gas or oil. And so we relate this to our oceans because the oceans cover so much of our planet. Much of our oil and gas reserves are beneath the ocean. And so that resource, which is a finite resource, meaning that it will run out at some point, understanding where it is and how to get to it safely are concerns that relate to the ocean. Another one that a lot of people don't realize is a resource that relates to the ocean is sand and gravel. And you might think, well, what's the big deal about sand? We use it, sandboxes, we go to the beach, what have you. But sand and gravel from the ocean are where we get most of the material to make glass and other kind of things that we use on a daily basis. Glass is the biggest one. In the beach sands, there's a higher concentration of quartz grains, and that's due to geologic weathering of rocks. And because those sands are high in quartz, we basically mine that sand and gravel to pull quartz out and process it to make glass. And so we're actually running into a problem where we are running out of sand. There's a great documentary called Sand Wars. If you ever get the opportunity to check it out, do so. It talks about the battle that is happening over sand resources. Many places are having less and less sand available for the purposes we need it for. So that's another resource that is specific to a lot of coastal regions. All right, another resource you might not think about is transportation and recreation. Our oceans and our coastal regions supply the means for which we can transport material across the country and the world. So it's much less expensive to transport cars, for instance, across the Pacific Ocean from Asia to the US than it is for us to bring them across in airplanes, right? You can fit a lot more cars on a boat and sail it across the oceans. So understanding our ocean conditions, all these things we've been talking about all term, help us navigate the oceans for transportation, cargo, those types of things more easily. Recreation is another one. This is a resource, right? So think about Hawaii, right? Hawaii has these beautiful beaches for surfing and all these things that they utilize that area for recreationally, scuba diving, things like that. That is a resource for Hawaii and other places around the world. That ocean resource of recreation and tourism brings in a lot of money for that region. And so it's very important to make sure we understand how ocean resources such as that can be maintained and utilized appropriately. Okay, another one, and you guys are watching the video on coral reefs, and so this one is hopefully at the forefront of your mind. Biotechnology. So we learned this week, or last week, sorry, about the diversity in the ocean. How evolution has produced these adaptations that have survived because they've added a benefit to those organisms. And in that benefit, say for instance, the venom of a cone snail that helps it eat its food, we've actually been looking at these things and researching them as to how they can benefit us, right? So I put up a few examples here. I just talked about the cone snail. That's this organism right here. And they feed by basically enveloping their prey and inserting a venom that paralyzes them, basically. But that toxin that they use for doing that, we are researching to utilize within us as a pain suppressant, non-addictive forming pain medication to treat all sorts of things, right? Sponges, we talked about how sponges do their thing. Well, there are antiviral drugs within sponges that we utilize to fight off various viruses. There's other things that help us fight cancer, right? Sea hairs. This thing right here is a sea hair, and we can take things from that and utilize it to create cancer-fighting drugs, right? And so these organisms that have evolved over millions of years and have these amazing adaptations, we're learning how those can help us. There's an organism that produces something that helps with treating asthma, for instance. So one of the things that we talk about in the end is coral reefs and how important those ecosystems are. And we want to save those ecosystems not only for the organisms. I think we should save them for the organisms, but many people think that for purely selfish reasons, those ecosystems where corals are and there's all these adaptations can end up helping create life-saving drugs for us. So there's kind of a twofold reason to save those ecosystems. And also, coral reefs provide a lot of economic resources for regions in fishing and food and things like that. So, but anyway, biotechnology is another resource to keep in mind when we're talking about ocean resources. Okay, so those are just a few highlights of some of the bigger resources that are out there. There's many more kind of smaller end ones, but just for the sake of time, we'll focus on those main ones I just talked about. Now I want to talk about pollution and how those things kind of relate to pollution in our oceans. Okay, so marine pollution is a huge issue for a lot of different reasons. Pollutants can get into the natural system and interrupt various processes. These can affect living beings. They can also affect physical processes in the ocean. And so we want to be able to understand those things and how they relate to various things like habitat destruction, right? How does the rise of CO2, for instance, which is a pollutant, decrease coral reef development, for instance? How does it relate to the loss of seagrass, right? So when we get pollutants into our coastal regions, that messes with the seagrass development, and so on. So we want to understand this a little bit more. Okay, so when we talk about pollutants entering in the ocean, there's a variety of places where that can come from. Air pollutants, for instance, account for 20% of the pollution entering into the ocean. Transportation, so boats moving across the ocean, industrial waste, drilling, offshore drilling for oil and natural gas, litter. Sewage is the biggest one, 30%, basically runoff from our sewer systems makes its way into the ocean. And then farm runoff is 20%. These two things right here, 50% of the pollution that enters the ocean is basically from runoff from land-based material, whether it be sewage or farm runoff, things like fertilizer and things like that making its way into the ocean. And so we want to understand these things and how they are affecting the ocean system. Okay, so one of the things that we look at is obviously the input of this material into the ocean. But sometimes taking things out of the ocean can cause quote unquote pollution as well. So one of the things we think about is desalination. If you don't know what that is, desalination is basically reducing the salt content of ocean water to zero so that we can use it for drinking water. It's a huge topic right now because of droughts in various regions. But desalination, basically changing the ecosystem of a coastal area because you're removing salinated water, all right, water that has a salinity to it, to fresh water so we can use it for our purposes, that changes the ecosystem, right? So that would count as a pollutant, but in the opposite direction, where you're removing something from the ocean environment. Okay, so why we talk about this is that these pollutants, or things that get into the ocean that normally wouldn't be there, or at least not be there in the concentrations that they are, is because they affect the way that the physical systems operate. Not only the organisms, but also the air systems and flow within those ecosystems. And it can affect the quality of life for not only the organisms in the ocean, but also organisms out of the ocean. And we'll talk a little bit about that in a second. Okay, so petroleum is probably one of the biggest concerns with the ocean pollution, and that's because of how we utilize it, and it's more than just the one type of interaction with the ocean. So if we have an oil seep, a natural oil seep in the ocean, it tends to be pretty small, but it does happen. It happens over time. It's a natural process. Oil seeps out from vents within the ocean. That's a natural process. But we also go down and drill into the ocean, into the crust beneath the ocean, and that process has the opportunity to have large-scale oil catastrophes, leaks, and things like that, such as the BP oil spill that happened not too long ago. Transportation, right? Moving the oil from this place to shore, those ships have oftentimes sunk and released oil into the ocean. It doesn't stop there though, right? Once it gets out of the ocean, that oil and gas, we utilize that to power cars, airplanes, factories, and things like that. And the byproduct of that makes it into the ocean, up into the atmosphere. So it isn't, when we talk about oil pollution, it's not just this one thing here. It is a massive issue because it affects so many different aspects of the ocean environmental system. Not only the ocean itself, but also the atmosphere. So let's talk about a couple of case studies. I'm going to post these videos at the end of the lecture. One, it just covers the BP oil spill that happened in 2010. A massive, massive oil spill that went on for days and months before they were able to get it under control. And we're obviously still seeing the effects of that oil spill. So make sure you check out that video. I won't post a video for this one. In March 1989, the Alaska Exxon Valdez catastrophe. It was basically a ship that was carrying oil sunk, and that oil is still washing up on shore in Alaska today, right? And the main reason why we care about the immediate impact of these is because it affects the ocean life directly, right? So there's some otters that have themselves covered in oil. We've all probably seen the pictures of birds. But then it gets into the ocean water and things like shrimp and fish. It affects everything. The BP oil spill greatly affected the fishing industry and shrimping industry in the Gulf Coast, even today, making sure that the fish there aren't contaminated with the byproducts of that oil spill. And so make sure you check out that video I post related to the BP oil spill at the end of this lecture. Okay, so when an oil spill happens, how they go about cleaning it up is tough, right? There's a couple of different ways of doing that, but they have negative impacts as well. So dispersants, such as Corexil, this is something that they basically put into the water that binds to the oil and it sinks to the bottom of the ocean. So it doesn't take it away, it just kind of takes it out of our sight, which has its own issues related to it. Trying to physically remove the oil using things like skimmers, that's this right here. A couple of boats skim the surface of the ocean water to pull out the petroleum. It gets some of it, but it definitely doesn't get all of it. It only gets the stuff at the very, very surface. Burning it off is obviously another option, but you can imagine the results of that aren't good for anybody as well, because you burn that and it goes up into the atmosphere and it interacts with the rain and gets back into the ocean in another form. So cleaning up after an oil spill is difficult, and we want to make sure that we try to avoid doing that as much as possible, because it is a major pollutant in the ocean. Okay, so something related to this, when things, just in general, when things get into the ocean, there's a couple of terms you want to be familiar with related to pollution and how it affects organisms. Something called bioaccumulation and biomagnification. And they're two different things, so I want to focus on them individually. Even though they sound very similar, I want to give you the differences between the two. So bioaccumulation is related to an individual organism. It is basically how much of a substance, a pollutant, toxin, or whatever it might be, is accumulating within an individual. And it can take a long time. It can be a lot, it can be a little, it all depends, but it's just talking about what is the quantity of material within an individual that is a pollutant or a toxin or whatever it might be. Some of the major ones that we've found in the ocean are listed down here. I'm not going to read through all of them, but for instance, dioxin. This is something that's been found in the ocean, and it is found to cause skin disorders, cancers, and genetic mutations. Trichloroethylene, liver and kidney damage. And so not just within an individual that these cause that, but if we were to eat this organism, those toxins and stuff could, affect us as well over time. So again, accumulation is the accumulation of a substance within an individual. When we talk about biomagnification, this is where we start to get into how it affects the greater ecosystem of the ocean as a whole. So this is also known as amplification, but basically what it is it takes the accumulation that's within an individual, and because, as we remember from our food web in the ocean, things eat other things all throughout the ocean, and so it can magnify at every step, right? So remember how we said that only 10% of the energy makes it through to the next level in the food web? Well, that means that an organism that is eating something from the level below has to eat a lot of it to get the energy it needs to do its daily, functions. And so if you have something like a zooplankton that has a little bit accumulated within the individual, well, every individual within that community has some accumulation within them. And so you have a larger predator that eats, say, all 4 of these. Well, now this predator has taken in all of the accumulated toxins from these individuals, which means it has now magnified within this organism. Well, this now has magnified the results, and there's other fish in the same situation, and so the next predator up, the bigger thing that eats that, will accumulate and amplify the toxin that was in the prey below. And then you get something like an orca, which will eat 20 or 30 of these, and now it's accumulated more. So magnification is basically the exponential growth, exponential increase of the toxin, because further up the food web you have predators that are eating more and more of that material, and so they're magnifying the effects of that substance. So think about that. Bioaccumulation and biomagnification amplifies the effects of toxins and pollutants entering into the ocean. Okay, another thing that we care about in the oceans are heavy metals. Now, there is a lot of naturally producing metals in the ocean that are released on a natural level, but from runoff from factories and other things, we actually input a lot of other metals into the ocean. And these are the biggest ones: lead, copper, and mercury. Here's the natural heavy metal input into the ocean. You can see that our input into the ocean is pretty large. Why does this matter? Well, it matters again to that bioaccumulation and biomagnification. You've probably heard that you're not supposed to eat a lot of fish, right? Some fish is good. Fish is definitely good for you. I eat fish probably a couple times a week, and they say to basically keep it around that number, 2 to 3 times a week. Any more than that, you risk biomagnification, and that is because in the ocean, methyl mercury will make it into the primary producers by seeping through the water, and because that magnifies up the food chain, typically the fish that we catch to eat has amplified those results. And so you want to limit the amount of fish you eat so that you don't accumulate more of the methyl mercury in the system. And so that's just something to keep in mind. Again, fish is good for you; it's good to eat, but everything in moderation, right? Okay, eutrophication. This is another form of pollution. It typically relates to input from runoff from shore. And so basically what happens with eutrophication is typically near shore environments, so coastal regions like the Gulf Coast sometimes experiences this. As rivers and streams and runoff from the land enter into the ocean, it brings with it a lot of nutrients. And typically, right, nutrients are good for organisms. But if you have too much, nitrogen, too much of phosphorus which is used in fertilizer, if you get too much of those nutrients into the ocean, then you get a massive increase in biological life, such as algae. And when algae blooms, it basically brings in a lot of sunlight and increases the photosynthesis. It increases the organisms' interactions here. And then when that input stops, now those organisms start to die, and it reduces the amount of oxygen, and that chokes out the system. And so you lose oxygen over time because of a massive influx of life that dies off, and then you get a choking of the system, and you get a lot of die-off. So eutrophication happens from this increase in nitrogen and phosphorus, which is typically from a runoff from coastal regions. Okay, lastly, plastic in the ocean. This is a big concern, and I'll have a short video at the end of this as to why. I think it's pretty obvious that plastic is not good in the ocean. It accumulates, and it obviously looks horrible. This is, I believe, off the Indonesian island where it accumulates. But one thing I want to chat about is you'll oftentimes hear something like the Pacific garbage patch, right? Or that this large island of plastic in the ocean exists. And it's both right and wrong. So I want to clear it up and basically make it very clear what they're talking about. Plastic is a big deal, but it's not in the ocean is the big deal, but it's not the solid plastic such as this. So for instance, if you go to the middle of the Pacific Ocean, right, this is what you will see. You will not see a big island of plastic or trash in the ocean. I mean, you will see trash there. You will see little bits and pieces of trash. You will sometimes see something larger. But this is, if you remember from our discussion on gyres, the middle of the Pacific gyre. Now, there is no island there. It is the plastic that is there is dissolved. It is broken down over time as it makes its journey and being pushed to the middle of the Pacific Ocean gyre, and it breaks down. What you do find, though, if you were to take a jar full of water from this region, you would find an increase, a massive increase in the amount of dissolved plastic in the water, which is not healthy. Not healthy for fish to basically use that water to do their thing, not healthy for the birds that eat those fish, and so on. And if you sift out, which is what they do here, you do find small microparticles of plastic in the ocean and things like that. So definitely a huge deal. We want to reduce the amount of plastic in the ocean for a variety of reasons, but there is no big, plastic island in the middle of the Pacific Ocean. Okay, so why are we talking about all this? How does this all relate to us individually? Well, it comes down to supply and demand, right? Our population is massive, and we require a lot of stuff, right? We require a lot of goods, food, what helps food grow, fertilizer, things like that. Well, that fertilizer, as we just saw, has runoff associated with it, which causes nutrient availability in the ocean to increase and all these things. We use a lot of plastic. All of these things come down to our population. And as we transition from this discussion on resources into our next lecture, which is going to be on climate change, it is important to understand why our population growth is such an issue. And so make sure you check out the video at the end of this that relates to population, and then we'll get into the next lecture, which is going to be global climate change. All right, thanks.